So practical transformer. So here this is the primary winding where the alternating voltage source is connected. This is the secondary winding where load is connected. In between primary and secondary we have this iron core. So R1 and JX1, they are the primary winding, resistance and reactance, leakage reactance, right? So V1 is the applied voltage and E1 is the induced EMF, right? And here this is R2 and JX2, this is V2, this is I2. V2 is the load voltage, this is the secondary winding, right? E2 is the induced EMF. So dot shows the same simultaneous polarity. That means at one particular instant, if this is positive, then this dot will also be positive at that particular instant, right? N1 number of turns in the primary winding, N2 number of turns in the secondary winding. So here we have discussed that I1 will be equal to I0, or the exciting current, or the no load magnetizing current. I0 is IE, that is exciting current or no load magnetizing current. I2 dash is a load component which is present in the primary, right? So I1 is equal to I2 dash plus I0, right? So I2 dash, you know that it is N2 by N1 into I2 plus I0, right, equal to I1. So that means you can write this whole equation in this way also, right? N1 I1 minus N2 I2 is equal to N1 I0, or you can say N1 I1 is equal to N1 I0 plus N2 I2, right? We have discussed this already in the operating principle of the transformer. So apply Kirchhoff's voltage law in this loop. Apply Kirchhoff's voltage law in this loop. So you will get E2 is equal to V2 plus I2 R2 plus JI2 X2. E2 is equal to V2 plus I2 R2 plus JI2 X2, right? So let N1 is greater than N2. That means suppose it is a step down transformer. So turn ratio A. Let me define turn ratio by small letter A. In some books it is represented by small n, right? So here let me represent this turn ratio by A, small a. Small a is equal to N1 by N2. It is greater than 1 for a step down transformer, right? Let us assume it is a step down. So N1 is greater than N2, so turn ratio is greater than 1. Now here apply Kirchhoff's voltage law in this loop. Here you will get V1 is equal to E1 plus I1 R1 plus J I1 X1. Now this transformer, this is the physical circuit. Now you can represent this into electrical equivalent circuit, electrical circuit. This is the primary winding R1 plus JX1. This is the transformer winding. This is transformer primary winding leakage reactance. This is primary winding resistance, and this is the windings of the transformer, right? Two parallel lines, they represent the core, iron core, right? V1 R1 X1 I1, E1 E2 R2 JX2 I2, and this is V2. This is load, right? Right. Now come to this, right? So you can further simplify this. So here just refer this secondary side to primary side for further simplification. So V1 R1 JX1 I1, this is the shunt branch consisting of core loss component RC and magnetizing reactance XM. XM is the representative of magnetization of the core, RC is the representative of core loss, IC is the core loss current, IM is the magnetizing current, and IE is the exciting current. IE is also called I0, that is the no load magnetizing current or simply exciting current. Both are one and the same. IE and I0 both are one and the same. So R2 dash, when you refer this secondary side quantities R2 JX2 I2 and all V2, all these things, when you refer to primary side, they will become R2 dash, J times of X2 dash, I2 dash, V2 dash, E2 dash, right? What is the meaning of this dash? So this meaning is that, so this shunt branch is in between primary and secondary, right? So what is the meaning of this dash? You see here, I2 dash means I2 by A, R2 dash means A square R2, X2 dash means A square X2, E2 dash means E A times of E2, right? I2 dash means I2 by A, R2 dash means A square R2, X2 dash is equal to A square X2, E2 dash is equal to A times of E2, right? So basically we have referred secondary side quantity to the primary side, and we have combined these two circuits. We have combined these two electrical circuits, right? So simply we get this, right? So this is equivalent circuit referred to primary, right? You can also refer to primary to secondary, right? But the normal practice is that we refer secondary side to primary side for ease of calculations, right? So that's why R2 dash, JX2 dash, I2 dash and V2 dash and E2 dash, right? Now apply Kirchhoff's voltage law in this loop here. So E2 is equal to V2 plus I2 R2 plus J times of I2 X2, right? Here in this loop I am applying KVL in this loop. So E2 is equal to V2 plus I2 bracket I2 R2 plus J I2 X2, right? Now here when you refer this secondary into primary side, it will become A into E2, right, is equal to AV2 plus AI2 R2 plus J times of AI2 X2. Or you can say you simply multiply this whole equation by turn ratio A. So A multiply here in the left hand side, A multiply here in the right hand side. So A times of E2 is basically E2 dash, right? E2 dash, E2 dash. So E2 dash is equal to A times of E2, right? So that is equal to E1, right, is equal to V2 dash plus I2 by A. AV2 is V2 dash plus I2 by A into A square R2. What I did, I simply multiply A in the numerator and divide A in denominator. So here it becomes A square, and here it becomes A square, here it becomes A. So I wrote this I2 in form of I2 by A. Here A square R2 plus J I2 by A. The same I did here, A square X2, divide and multiply by A in numerator and denominator, multiply and divide by A in numerator and denominator. So here A square X2 divide by A, so I2 by A. So here it becomes E1 is equal to E2 dash is equal to V2 dash plus I2 dash R2 dash plus J times of I2 dash X2 dash, right? So these are the values, that means secondary side values, which are referred to primary side, I2 dash, R2 dash, X2 dash, E2 dash. So rated voltage is V2 dash, rated voltage is V2 dash and not V1. So keep in mind. So first approximation, shifting shunt branch to input terminals, right? Shifting shunt branch to input terminals. So earlier the shunt branch was here, now you further shift it to input terminal, that means towards supply side V1. So V1 I1, this is the same shunt branch containing IC, RC, IM, XM, and this is IE or I0. Here this is I2 dash, R1 JX1, E1 is equal to E2 dash, R2 dash JX2 dash, here V2 dash, right? Okay. So here rated voltage is V2 dash and not V1, right? Rated voltage is V2 dash and not V1. So here you can ignore this, right? I mean, need not to show this, right? Or you can show. So first it was E1 square by RC, now it became V1 square by RC because shunt branch is shifted to supply side. So now it become V1 square by RC. So V1 square by RC greater than E1 square by RC, right? So if you shift this shunt branch towards input terminal, so now core loss will increase, core loss बढ़ जाएगा because V1 is greater than E1, V1 is greater than E1. पहले I1 स्क्वायर R1 था, राइट? अब हो गया I2 स्क्वायर इंटू R1, दैट मीन्स I1 स्क्वायर R1 ग्रेटर देन I2 स्क्वायर R1, राइट? कॉपर लॉस बाद में कम हो गया, राइट? शंट ब्रांच को इनपुट टर्मिनल की तरफ शिफ्ट करने पर, राइट? इफ़िशियंसी पर कोई खास फर्क नहीं पड़ेगा. सो दिस इज़ द सर्किट फाइनल, राइट?